This is the meat of a lot of what we do in terms of methods. It's big. I'm going to try and reduce it to a reasonably short presentation and go over some of the stuff in more detail in Microsoft Teams when we're meeting. But there's a couple of different ways of coding text, and I take the word text to mean a whole lot of things for meaning. One is the way the social sciences do, which involves close reading of textual sources and coding them based either on patterns that you discern and that emerge from the text as you read it, which is the traditional old-fashioned way of doing history, where you go to the archives and read all the documents and see what comes out of them and then find the patterns in it and therefore write up your interpretation. Or you can do it the more social sciencey way rather than the humanities way, is to actually decide what your research questions are first, develop your coding schema, and then apply that to the documents. Digital humanities approaches text in a very different way, and a lot of it goes to the work of Moretti and various variations on that in terms of distant reading. And it mainly, it falls into two things. One is sort of stylometric work using OR, mostly, text analysis tool, very like Python, requires some coding therefore, or using topic modeling. Mallet is the most common tool. Stanford had a very nice one, but they don't support it anymore. Both of those rely on reading large chunks of text. I've put these slides in the wrong order. And finding words that relate to particular topics. So they go through the topics and find words that relate, and it's easier to see in this. This is a bad example because the two halves of the diagram here of this diagram are actually about two different subject matters. But in this one you can see here where the topic modeling tool searches for words which are, for example, related to football, or words which are related to business, or a few words which are related to the environment down there. Right, so it pulls out lists of related words and it then maps them across the diagram or across the extent of the text or the corpus of texts to show where they occur. So this is a much more common visualization of topic modeling. Again, picking out it's very like what we've done in many of my classes in terms of annotating a text. Except in this case, of course, they're using a different color for each topic. And they're producing a map that shows where the topics occur, where they're distributed across the text. And a list of the words here associated with each topic. This is a genetic one, so gene, there's a whole family of things to do with life, evolution, organizing, there's brain, neuron, nerves, grouped together, these words. So, I mean, it has its advantages. It also has, you can do wonderful things with it. You can then map the relationship of the different topics and visualize how they relate to one another and how they cross-reference. The problem with this is, of course, that many of the tools do not have a nice graphical user interface, which is problematic. Many of them require you almost to write code. Mallet has a minimal graphical user interface that simply doesn't require you to write the line of code correctly. It just gives you dialog boxes to input the variables. And the different number of segments you use can change the number of topics. How many topics you tell the program to go looking for. How finely do you focus it? It also is problematic with things like, for instance, poetry, because poetry uses lots of image and figurative language. So across the spectrum of different types of text, it has variable values. Voyant is probably the most accessible, best text analysis tool for the humanities, the product of decades of work by Stefan Sinclair and Jeffrey Rockwell in Canada, and it's come to a stage where it's got a beautiful user interface. So you put a piece of text into it. The first screen is very bare. You paste your text in or give it a URL, and it will then go through that text. It will arbitrarily divide it normally into 10 segments. The default is to produce a word cloud of the most common words. It will tell you some stuff about the text in the document. It will also show you the words in context. So here, this is from the debates in the UK Parliament about the European Community Act in 1972, when Britain was joining the European community. And so I've clicked on the word Parliament here, which is one of the most common words in the visualization. And it shows me the distribution of that across the day's debate. And it also shows me useful things like the keyword in context. So this shows me for every instance of the word Parliament, it shows me where what words occur around it, like accountability occurs, or proper processes, or approval of Parliament, words which in contemporary British political discourse are strange and are not heard very much. So it would be interesting to run current parliamentary debates versus the 1972 ones and see how these words and terms have changed their meaning. And Voyant will allow you to do that. And also, of course, all of these Voyant mini windows, you can change what goes in them. And if you hover over the top right-hand corner where the question mark is for help, it also shows you some options to change the tool in that window and also to export. Very important. Either a visualization or a URL for that particular piece of data. Exporting the visualizations or the data in various forms is extremely useful. It means you can get your results out of Voyant and paste them into your document. Big plus, right? So that's those. That's how the digital humanities approach it. Social science type subjects tend to approach it in terms of coding. So they take a piece of text and code the text. This is an old transcript from a set of research interviews with British political leaders in the 1960s. It was transcribed, there's line numbers, there's a space for some notes. This would all have been done manually or on manual typewriters. Or on stone tablets, it's that old. But it has codes. And how the codes works, there's two ways that you produce codes. One is that you read the text and highlight the things that are interesting and decide what topics these relate to. The other is you decide your research question ahead of time and you design the codes and then you apply them. And you may occasionally make up more codes as you go along. There's two different approaches here. This is very much a humanistic approach. This is the way historians would do it. Focused coding is the way social scientists would do it. People who study politics would do open coding. People who describe themselves as political scientists would do focused coding. Important distinction there in epistemological approach. So you can code the descriptive stuff. You can code stuff that is patterns, that deals with processes or issues, or you can code factors, which is the deep stuff, religion, social class, stuff like that, broad political issues, right? So these are some of the codes from that set of research interviews back in the 1960s and 70s for education, for family, for religion. You can apply these codes almost universally. You would have to add more codes for different education systems in other countries. And you would have to do some mapping to say which codes relate to which, but you can do that, which means, of course, that you can do more interviews using the same coding and study these things for other people. So this is your coding example again. You can do this by putting the text in a document. Google Doc, you could use a Google spreadsheet with different columns, and I'll show you that in a moment. There are programs, computer-assisted qualitative data analysis software, which are wickedly expensive. But what they will do is they will allow you to load in the text, have your codes set up in a code window, and then select a piece of text and apply the code to it. So in this right-hand side panel here, you can see the codes that have been applied to the interview, and they can overlap, which is great. You can do this sort of stuff. Also, this is where humanities, digital humanities text analysis falls down, and the social science side tools are better because you can treat anything as a text. So in this case, we have a video. It's actually a tutorial in an Australian university, and it was for teaching and learning and discussing what good and bad small group tutorials were. And you can select part of the timeline for the video and apply particular codes to it. And you also, of course, have a transcript there. Which, if you have a recorded interview, research interview, and there's any number of tools now that will produce a transcript for you as well. So you can match the two together, and that, of course, allows you to not only have the text, but also to see what people are doing. And the visual The people who are playing X's and O's in the back of the tutorial or something, you can pick that out. So once you've coded the passages, then you can pick them out under the different topics. Again, this was done manually, but with modern data analysis programs, you can go through these steps automatically. You can just replace the text with color coding if you want to. So you can start to step away from the actual words and begin to visualize the patterns, and then you can come up with this, which was done by a bunch of political scientists. I think it was in York. And this is the mental map, the meta-analysis of the factors that influenced Harold Wilson to join the Labour Party in Britain and become, in the 1960s, leader. And as you can see, things like the Depression is a large lump. There's a blob of that. And there's a lot of family influence and education and participation in religion and voluntary organisations. Marx, as you might expect, UK Labour Party, not very influential. So with that coding, you can take that coding methodology and apply it across the board to other elite political interviews, for instance, contemporary ones, and see how what has influenced people has changed. I imagine that left-wing political leaders now, anywhere in the world, are not deeply influenced in their politics by the 1930s Depression, because it was not part of their growing up experience. So you can see things emerge and go, and you can tell a story with a picture. And this is a way of doing it using spreadsheet. This is in Excel, but you can do it in Google Sheets, where the text is down one column, in this case down the left-hand column, and there's a bunch of columns set up for the different codes. And in this case, they've also been given a rough color coding to show which codes are kind of related. And you can simply just put a 1 where the code occurs in a particular segment. You just put a 1 there, boom, 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 boom. And at the bottom, you can then do a count. You can do math with it. So there is a convergence between qualitative text analysis and quantitative. Increasingly, at some point, we are putting numbers on things. Advocates of the way humanities used to do things would have argued that humanities scholars never put numbers on things. We always did it instinctively by reading the sources. And then I must get the pump off steroid. We would read the sources, right? That's the pompous bit there. And then form interpretations. But that act of forming interpretations was actually, the interpretations were formed based on how many times in your, let's say, historian's notes from the archives they found a particular thing turning up. So even though they weren't doing something like this explicitly, the actual methodology, however much, same with poetry. How many times do images of flowers occur in Wordsworth? Oh, well, we don't count these things, Well, actually, you did. Yeah, you did, all the time. So there was, at a certain level, this convergence of methods. But of course, the choice of how you code something is arbitrary. It is not strictly mathematical, because if you're going to take a line and say, this line is about X, that is a choice. Theoretically, people would say that distant reading and topic modeling is automatic. But the number of topics, the text you choose to submit, all of these things are choices. So really there's a qualitative dimension, even to research that seems very quantitative. And even where the research is appears to be quite quantitative, if you're dealing with human artifacts, there is a choice, a qualitative choice. One last slide, I think, which is, of course, that if you spent obscene amounts of money on the high-end computer-assisted qualitative data analysis tools, although there's a cheap student edition of this one, Max QDA, available, you can then produce this mapping, cross-mapping of which topics occur most closely to each other. And you can even do a co-occurrence model of topics. And this is very similar to what I showed you previously in terms of the sort of mapping that some of the topic modeling tools in the humanities will do, where they show how the different topics relate to one another. This just comes at it through a different route. In this case, the route is you manually apply the codes to the text, which could be an image or a film or anything else. Whereas in the more traditional digital humanities topic modeling, you point the program usually mallet, sometimes or, at the text, and it produces these automatically, and you tweak the variables to see what you get. So what do I want people to do? Generally, the exercise in this is to take a piece of text and to run it through Voyant and see what comes out, and capture some of the images like the word cloud and the distribution maps and put them and tell me what you are seeing, what results, what this is telling you about the text. And similarly, to take a piece of text and throw it into a spreadsheet and make some columns down the side and show that you can understand how to basically just apply some codes. So design half a dozen codes and mark them up down the bottom, and then in your thing count how many times these codes occur in this segment of text. And if you can get that far, then you can work out how to build fancy charts and tables for them if you need to, right? So that's roughly that. So now I will save this and hope that it saves properly and processes and reduces, and I will go back to ye olde pompous academic stuff.